So this video is going to be about simulating optical microstructures on the surface of thin film devices. So very often you want to change the optical properties of the surface of your device to enable light to either escape very easily or to enter very easily. Good examples of this are OLEDs and solar cells, where, for example, in OLED you might want the light to escape very easily to make sure it's very efficient at emitting light, and also you might be concerned that the viewing angle is very good. You might want the light to escape evenly in all directions maybe. So you might want to change the surface to enable that to happen. The opposite example is a solar cell, where you might want light to enter the device very easily and get sort of trapped in the device. And you can do this by introducing optical microstructures on the surface of your device, such as lenses and ruffling the surface and things like that. So we're going to look at simulating that today, and there's a bit of a tutorial on that, and using gpvdm to do that. So to do this, we're going to click File and New, and the simulation we're going to select is we're going to have to scroll down past organic solar cells, perovskites, IMPS, OFETs, optical filters. We're going to go down to micro lens ray tracing demo. So if we double click on that, it'll ask us where we'd like to save it. We're going to save it on the desktop. I'm just going to call it My Test Simulation and just save that. And the structure it presents us with is this. It's effectively a layer of metal, I think there's aluminium, some organic material, and some micro lenses on the organic material. And these lenses are actually made of the same material as this layer here. And to give you some idea of the size of this device, if we look on the XY size, you see it's 800 nanometers by 800 nanometers. So each one of these lenses is tiny. I guess these could have been made by etching or something like that. So if we just go ahead and run the simulation, it'll simulate a few wavelengths which will run from 500 to 700 nanometers. And if we look at the output, you can see it's simulated how sort of the rays would propagate in this device. So it's taken from a point source in the center of the device, and it's in the center of this red layer here. And you can see that there's very good coupling. This light's effectively very well trapped in this red layer here, and light's can sort of escape through these lenses at the top. Not much light's escaping, so most of it's trapped in the center, which is just a function of the design of this particular film. So what you could do now is you can go and look at this light as a function of wavelength. So that we're looking at 500 nanometers now. Let's look at 600, and you can see how orange light would propagate in this device, or orangey red. Now what you could now do is you could go and play with this design to try and improve the light being removed, or the light coupling externally from the device. So to do this, we click the right-hand button on the lens, and we go to Object Editor, and we get this Object Editor window up. And what this Object Editor allows you to do is effectively edit all of these sort of microstructures effectively on the surface. So here we've got a dome, but we can have a pyramid or a box or whatever we want. We'll look at those a bit later. But for now, we're going to change the height. So this is dy height of object from 800 nanometers to 1800 nanometers just by putting a 1. And you see all of a sudden the domes have sort of increased in shape. So you've got more sort of taller lenses effectively. So if you run this again, you can see now that light's bouncing around inside the lenses more, and it looks like it's got a better chance of escaping. So obviously you could go and run some sort of statistics on this and find out, you know, how your light's escaping. So that's one thing. So what we can do now is we can look at effectively in more detail how the light's escaping this structure. So to do that, what we can do is turn off this device. At the moment, we've got this device view plotted, and it's sort of hiding what's happening a lot in with the ray tracing. So if we click off device view, we just see the rays within the device. And indeed, we can actually see all the rays are basically captured within this one layer here. Now, what we can, at the moment, we're projecting 20 rays around this way and 20 rays around this way. So we're sort of exploring the space. I've called this angle here theta and this angle here phi. So we're sort of exploring that space by projecting rays out from lots of different directions. And we can change how light rays are launched within the device by going to Configure, by going to Simulation Editors, and then going Ray Tracing Editor. And here we can change so theta steps and phi steps. So those are two angles through which the light's launched. So if we change theta steps down to 1 and change phi steps from 10 to 20, so now we're just launching light horizontal to the structure of the device. So run this, and we can see that light sort of irradiates from this point here and bounces off various structures. This enables you to study light in one direction or the other within the device to try and get a better understanding of what's going on. Now what we can do is if for example we wanted to explore, we'll put the device view back on, we want to explore, so that light sort of in one of these layers here, if we want to explore how light bounces around these micro lenses, what we can do is we can change exactly at what level that light's launched at. So if we turn off the, let's go that way, and then if we turn off this device view, and then if we turn off, and then if we turn on light sources, you can see we get a little blue box there, and what this blue box represents is the position in the device where all the light is launched from. So what we can do is we can simply just drag this up a little bit and then rerun the simulation and look where that is, device view. So actually that's just above those lenses. So if we bring that point back down a bit, there we go, it's actually midway within the lenses. Not quite, it's a bit fiddly. Bring it down a bit like that. There we go. We're actually now launching light. See, there's the little box. We're actually launching light within one of these lenses, so we can study exactly how light trapped in one of those lenses will sort of propagate and go throughout the device. And it's quite interesting because what you can now do is you could change that particular structure from the domes to a different shape. So we could change that, for example, to a box. And so there's some boxes, and we should adjust the properties of these boxes. So we'd have them, say, rather than 250 nanometers wide, we'd have them 100 nanometers wide. And what we could do, so we now got a lot of boxes in the corner, and we'll just rerun that for fun, and you can sort of see how the light's interacting with those boxes. But what we're going to do now is we're going to spread those boxes out to form sort of a periodic structure. So we're going to go dx spacing is 100, so this is padding effectively I'm putting in between these boxes, and dz padding is 100, and that should a bit more maybe. Object as dz, and that maybe a bit more on this one. Maybe a bit less. $150. Can we get another row in? Then we can change a number of these. So we've got 4. Maybe I need to reduce the. How's that looking? I can probably get some more of those structures in. 6. No, 6 is too many. 5. 4. There we go. So now what we've got is we've got a series of effectively periodic sort of antennas or structures on the surface of our film, and we've got our light source in the middle. So if we just rerun the simulation, you can sort of effectively see how light leaves this light source, then bounces around our periodic structure. And with this, effectively, the possibilities are unending. You can change the structure and the type of the shapes as much as you want to simulate the type of film you've got. So that's it, really. That's sort of a brief tour of ray tracing in 3D and sort of micro lenses on the surface. I hope you find this useful. This is sort of the first outing of this 3D ray tracing. So if you've got comments or it doesn't do exactly what you'd like it to do and you'd like to sort of give user feedback, I'm very happy to take those comments on board and include them in the next version. So thank you very much for listening. I hope you enjoyed this.